Hello, geometry. This is the start of chapter 3. We're getting back into more of what is the geometry side of things. We're done with the logic and the reasoning and proofs. Proofs may still come up from time to time, but for the most part, we're just going to focus on the shapes and lines and different things like that. So, chapter 3, pairs of lines and angles. And our first is some vocabulary words here. We have the words parallel, intersecting, coincident, and skew. Okay, those last two might be a little bit new. First two, hopefully, they sound familiar for you. So parallel lines, we're familiar. I want to make sure you know this is the symbol for parallel lines. You see those triangles right there on your page, and that means we have parallel lines. So the number of points of intersection, you would have 0 points of intersection for parallel lines. So this symbol means the lines are parallel. So if they don't have that symbol, or if they don't tell you specifically these two lines are parallel, you cannot assume that, even if it looks like they are. They have to have the symbol, or they have to say line L is parallel to line M. Okay. So line M, line L, that's another way you write it. Line L is parallel to line M. So if you have two vertical lines, that represents is parallel to. Okay. Intersecting lines, we have 1 point of intersection, and coincident lines, we have all points. Or you can say infinite. So coincident means they are overlapping. They're overlapping lines. So that can happen a lot of times when you have 3 points and you have different ways to name lines. So I could say line AB is coincident with line AC. Okay, two different names, but it's basically the same line. Okay, so skew lines show up down here. It's when they do not intersect, but they're not coplanar. So you got to think of like a ceiling and a floor, and two different directions going here. So you got one going this direction, coming right at you, okay, and the other one's going across here. So you think of two airplanes flying in the sky, okay, they might be right on top of each other, but one is flying this direction, the other is flying this direction. If you look at the ceiling, look up in the classroom, you got the stringers from the suspended ceiling running one direction. Then you can look at the floor and you can see other things going the other direction. So those would be skew lines. Okay. So they want us to classify each of the following pairs of lines as parallel, intersecting, coincident, or skew. So AB and BC, they are intersecting. The reason? Because they intersect at B. Point B is our point of intersection. AD and BC, those would be parallel. They're in the same plane, but they won't intersect. They're in the same plane, won't intersect. The same plane won't intersect. EI, there's EI and IH. So again, these are lines. If you look at the symbol there, they're lines. These would be the I'll make sure I can spell it right. Coincident lines. And we know they overlap. Okay, so those are coincident lines. EI and IH, they overlap right there. Line BF. BF is back here in the corner. And EH is going along here in the front. Okay, so they're kind of going two different directions. BF is vertical, EH is horizontal. These would be our skew lines. So these are non-coplanar, and they won't intersect. A lot of times we say if two lines don't intersect, it's parallel. So now we know that it could be parallel or they could be skew, depending if they are coplanar or not. So EF and CG, EF is down here, CG is up here. Again, that's another example of skew lines. And it's the same reason as right there. Non-coplanar, they won't intersect. AB and GH. AB and GH. Those are parallel. Now they didn't draw it, but there is a plane that would contain both AB and GH if you slice it at an angle going through there. Okay? So those are coplanar, but they won't intersect. Okay? Coplanar, but they won't intersect. Okay, this is going to be new coming in. We're going to see a little bit more of this in chapter 2, but this right here, this word transversal, that is a transversal right there. Okay, when two parallel lines are intersected by a third line, it is called a transversal. We're going to see that coming up. The vertical angles, remember these are vertical angles, 1 and 3. That's a set of vertical angles. 2 and 4, that's a set of vertical angles. 6 and 8, there's a set of vertical angles. What color of it? Blue. 5 and 7, those are your vertical angles. Linear pairs form a line. Remember, 1 and 2 would be a linear pair. They form this line right along there. 3 and 4, linear pair. 1 and 4, linear pair. 2 and 3, linear pair. 5 and 6, linear pair. 7 and 8, linear pair. 5 and 8, linear pair. 6 and 7, linear pair. Lots of linear pairs. Linear pairs. Okay. So some vocabulary. We've talked about a lot of this already, and we're going to talk about this a little bit more. So hopefully this should be done after chapter 2. You got this done for today. Okay, your postulates that are new here. If there's a line and a point not on the line, then there's exactly one line through the point parallel to the given line. So if you're given this, and you're given that point, what this is saying is only one line that is through P can be parallel to L. That's what, oh, let me scoot it over. There you go. Okay. So if you're given the point, you're given a line, only one line that is through this point can be parallel to this. You can't draw another line that will be parallel to this. All other lines will be intersecting, or they could be skewed. We follow up the parallel postulate with the perpendicular postulate. Okay, perpendicular postulate says, okay, now I'm going to be given this line and this point, and we know only one, well, hello, only one line. I'm doing a class recording right now, so get a geometry lesson. Only one line through point P is not parallel this time, perpendicular to L. Okay, so only one line through point P is perpendicular to L. And that symbol, let's say this is a point, let's call that point S. We could say PS, line PS, is perpendicular to L. Okay, so if you see that symbol there, you know that is perpendicular to. And you remember now that's 90 degrees. Okay. So the final part of the lesson instruction here, these angles. These angles are going to be showing up a lot for this chapter and coming up. These four different names here: corresponding angles, alternate interior angles, alternate exterior angles, and then consecutive interior angles. So if you have corresponding angles, when they have corresponding positions, it's the same position on two lines. So we have two lines, they're being intersected by T. With corresponding angles, the letter you have a lot is you're going to be making an F out of those. So if I should use a different color here. If I draw these in, There's angle 2. And there's angle 6. Okay, looks like a double L, but if I kind of move it around here, you kind of see the F that's being formed. A lot of these questions moving after this section are going to be done with parallel lines. It's going to make some of these letters show up a little bit better. Okay, so there's an F. Remember, corresponding positions. This is in the top right. This is in the top right. If I just look at these 4 angles, 2 and 6 are corresponding to because they're in the same general location. Okay, I could put a 1 here and a 5 here. 1 and 5 would be corresponding. So 2 and 6 are corresponding, 1 and 5 would be corresponding. I could put some more down here. This would be 3 and 7. So 3 corresponds with 7, and this is 4 and 8. 4 corresponds with 8. Hopefully you see how those positions work out there. Okay, alternate interior angles. Alternate, you got to think on either side. It's alternating. Things are alternating. You do one side, then the other side. Interior, you need to be thinking between the 2 lines. Between the 2 lines. So when they lie between the 2 lines, there's that phrase, between the 2 lines, and on opposite sides of the transversal T. So this is there's that word transversal again. 4 and 5. All right, so if I highlight those, sometimes it's easier than others. So here's 5, here's 4. I usually think of this as a Z shape. Okay, if it's of that Z shape, you have alternate interior angles. So F was corresponding. Z shape is alternate interior. So 4 is alternate interior with 5. If I put 3 and 6 on there, 3 would be alternate interior with 6. So 4 and 5, 3 and 6. You notice with 2 lines cut by, this is referred to as cut by a transversal, we had 4 sets of corresponding angles. We had 2 sets of alternate interior angles. We go outside the lines, so if this is the inside, that makes this the outside, and this the outside. So we have 2 angles or alternate exterior angles when they lie outside the 2 lines and on opposite sides of the transversal T. So this one's, you have to use your imagination a little bit more. Keep getting tougher. Here's 1. So here's angle 1, here's angle 8. If you get a better idea, please feel free to share it with class. If I put these together, you kind of get an X shape. See that? If I'd combine them, there's an X like that. So we know angle 1 would be an alternate exterior with angle 8. If I put a 2 and a 7 in there, those are on different sides. 2 would go with 7. Okay, so 1 and 8 go together, 2 and 7 go together. Final one are consecutive interiors. So again, we have to be on the inside. Consecutive means the same side. Sometimes these can be called same side interior angles. The consecutive, it helps to, let's do green. Here's angle 3. Here's angle 5. Consecutive can be a C. Turn around here. You see the C? Can you see the C? Not from Kansas, you can't. So there's the C, 3 and 5, those are consecutive interior angles. 3 goes with 5, I could put 4 and 6 in there, 4 goes with 6. So when we have 2 lines cut by a transversal, we had 4 sets of corresponding angles. We had 2 sets of alternate interior, 2 sets of alternate exterior, and then 2 sets of consecutive interior angles. Let's go look at these questions first, 9, 10, 11, and 12. It's kind of confusing when they do 3 lines like this, so I want to work with you together on these. Let's try to figure out what are your corresponding angles here. So I'm going to start down here with 1, and we're going to have lots of different sets of corresponding angles. So 1 is in the kind of the bottom left in this corner. That would correspond, think about which angle over here would it correspond with, and which one over here. So angle 1 is is going to correspond with angle 5, and that's going to correspond with angle 9. Okay, they're all kind of on the left bottom of the lines. So 1, 5, and 9 would all be corresponding angles. Let's go to 2. 2 is kind of above 1, so that would correspond with 6, and that would correspond with 10. So angle 2 corresponds with angle 6, corresponds with angle 10. 3, that was to the right of 1, so that's going to go with 7. 3 corresponds with 7, and that corresponds with 11. So angle 3 corresponds with angle 7, which corresponds with angle 11. And the final one, 4, 8, and 12. So angle 4 corresponds with angle 8, corresponds with angle 12. Now, written on that, I have 3 more questions to do with those, hopefully. Oops, probably shouldn't have done that. Alternate interior angles. Alternate interior. So interior. So if I look at these 2 lines right here being cut by this transversal. Alternate interior, 2 would go with 7, because they're both inside. So angle 2, angle 7, and 4 would go with 5. Angle 4, angle 5. Okay, let's pick another 2 lines. So I'm going to pick this line going up and this line going down. So these are my 2 lines cut by this transversal. So here's my transversal. The angles have to be on the transversal. So 3 alternate would be on 10. 3 with 10, 4 with 9. Angle 3, angle 10, angle 4, angle 9. And the other 2 lines, so I did 1, 2, I did this one and this one. I need to do this one and this one. That one and that one. So here's my transversal. This is my transversal now. So the angles have to be on there. So that'd be 10 and 8, 7 and 12. 10 and 8, angle 7, angle 12. Okay, alternate exterior. Go through the same thing. Alternate exterior. If you can pause this, go ahead. Try to get them down. Jump ahead to these answers then. Come back. Alternate exterior. So again, I'm going to start. Here's my transversal. So 6, exterior has to be on the outside. 6 has to go with 3. 8 has to go with 1. So angle 1, angle 8, angle 3, angle 6. So for that transversal. So now let's do this transversal down here, intersecting these 2 lines. So here's my transversal. Outside of that would be 1. Opposite would be 12. So 1 and 12, 2 and 11. Angle 1, angle 12, angle 2, angle 11. And my final transversal is this one. So outside the 2 lines, 5 would go with 11, 6 would go with 9. Angle 5, angle 11, angle 6, angle 9. So notice if you can focus on the transversal, that'll help you know, okay, I need to be outside the lines, inside the lines, where do I need to go with this? Consecutive interior, last one with this. So again, so if this is my transversal, consecutive interior, I have to be inside. 2 would go with 5, because now I have to be on the same side of the transversal. So angle 2, angle 5 would be consecutive interior. That puts angle 4 with angle 7. Angle 4 with angle 7. So that's my transversal. Now let's say this is my transversal down here. Consecutive interior, so they have to be along the transversal. 3 and 9. Angle 3, angle 9. Angle 4, angle 10. Angle 4, angle 10. 3 and 9, 4 and 10. Okay, final one. Here's my transversal. 8 would have to go with 12. They're between the 2 lines, 7 and 10. Angle 8, angle 12, angle 7, angle 10. There we have it. Got those 4. Let's go up to the top. Review some of these things. Think of each segment in the diagram as part of a line. Which lines or planes contain point B and appear to fit the description? So we have to contain point B. So which lines contain point B and would be skew to line FG? So here's FG. We want to contain point B and be skew. So if I go B to G, that would intersect. B to A would be parallel. So I think that would just be BC with a line on top of it. So BC with a line. And those are the three lines that contain point B that are drawn. That's the only one that's skew. We want the lines perpendicular to line FG. So perpendicular, you see the 90-degree symbol, so we know that's 90 degrees, so that'd be BG. And then one over here, AF. So perpendicular, you got to have that 90-degree symbol. So using the symbol, we could say FG is perpendicular to BG. That's how that symbol is used. It's an upside down T. Lines parallel to FG. Well, that'd be AB. Okay, it's in the same plane, has to be coplanar and parallel to it. And then EH. EH is on that back plane with it. Now sometimes you could accept DC, and I'm going to put that down here right now. That's kind of a one that could be forgotten here. DC, because it is coplanar, that plane would kind of go through an angle of that shape there. Okay, so that could be coplanar. So those three would be the ones we'd want to put down there. We want the planes parallel to plane FGH. FGH, that's the back plane. So we're just going to have plane, has to be the one in front, ABC, or ABD, or ABCD. Just need 3 points for a plane. BCD, BCA, however you want to put it there. Okay, so name a pair of parallel lines. We're using this diagram. You see these triangles in the middle. See how these two would be parallel to each other. These two would be parallel to each other. They put two triangles on these because it's not parallel to the lines that have one triangle. So a pair of parallel lines. We have WX is parallel to, see there's that symbol, is parallel to YZ. WX is parallel to YZ. We could also say QV is parallel to, sorry, not QV, that should be QR. QR is parallel to U or VU. Said U first, wrote the V first. Okay, those would be parallel with each other. Name a pair of perpendicular lines. Okay, so I'm looking, this is the only 90-degree angle that I know for sure. So I'm going to say ST is perpendicular to UV. Now we can argue that ST would also be perpendicular to QR because QR is parallel to UV, and we're going to get into that, okay, in this chapter here. So we don't have that proof or theorem yet, but you should be thinking like, oh, if it's parallel to this one and this one's going in the same direction, it should be perpendicular to that one as well. It's perpendicular to this one. Is WX parallel to QR? So where's WX? There's WX. Is it parallel to QR? No. Why not? No, I don't like that. I'm just going to put they intersect. Okay? That's why not. They intersect. Parallel lines can't intersect. Is ST perpendicular to NV? Is ST perpendicular to NV? We would say yes here. Okay. Now just say there's a 90-degree angle shown. You don't have to make it rocket science. Just say, yeah, it's 90 degrees there. Of course it is. Okay, I think that takes care of the notes and examples for 3.1. Hopefully this went a little bit easier than some of the proofs and some of the videos there. Keep up the good work. We'll see you in class.